All right, so here is today's learning goal. We're going to read it together really quick. So read along with me. Students will solve simple real-world problems using scientific notation and be able to describe the results in context. Very good. All right, so the main thing that I want us to focus on today, we're solving, sure. We're using scientific notation, of course, because we're in Unit 5. But this part right here, describe the results in context. Okay, what does it mean to describe something in context? What's going on around you, okay? If I were, as a teacher, I walked into a medical convention and I started talking about graphing calculators, would that be in any sort of context to what they do? Absolutely not. That would be totally out of context. In context means today when we're talking about people, when we're talking about dollars, we're talking about we're going to talk about weight of something, and we're going to talk about burgers. You cannot have a percentage of those things. Okay, you can have a percentage of $1, but to the reasonable amount where it's the cents or the change that you would have in with that dollar. So we're going to focus a lot on context today after we solve problems. So, $1 million. So I want you to read along with me on your paper in your head as I read out loud. In all of these tasks, you should show your calculations and give your answers to the nearest whole number. Okay, I want you to underline that. Nearest whole number, okay? A lot of things that we're going to talk about today, actually all the things we're going to talk about today need to be in exact amounts, okay? Or we're going to approximate and put them in exact amounts. Okay, so, and I also want you to show all of your calculations. That's very important today. Also, if you don't, you're going to get lost very quickly. All right, so this asks us, how many $3.50 burgers can you buy for $1 million? Okay, and there's representing a million by 10 to the 6th power, but I actually want you to write out 1 times 10 to the 6th power. That's the scientific notation form of $1 million. Okay? How many zeros does 1 million have? 6. Okay? So I want you to write out $1 million. Put the commas in the correct place. And where does the decimal naturally fall in 1 million? At the very end. Okay, so that tells us we're going to have this exponent right here to the 6th power tells us we are going to have to move how many place values? 6. And do we move 6 place values? Yes, so it matches. We're good. All right, so how many $3.50 burgers can you buy for $1 million? What do you think we're going to do? We're going to divide. We're going to divide 1 million by 350, because 350 represents what in this problem? 1 burger, okay? So we're going to take 1 million divided by 350, okay? And I want you to practice putting this number in scientific notation in your calculator. So turn your calculator on, okay? And I want you, whenever you use scientific notation in your calculator, you must use parentheses. Okay, you must use parentheses when you are using scientific notation. So this is the same thing as 1 times 10 to the 6th power divided by 350. Okay, so I'm going to have open parentheses. I'm going to do 1 times 10, and then the exponent sign is this little arrow on top of, or the key right above the division sign. Okay, the arrow above the division sign is the exponent. And then 6, and then you're going to press the arrow to the right to get out of that exponent level. It's going to bring you back down to the base level. Does that make sense? And then close parentheses. Now we're going to divide that by 350. And it's going to give you a value. Okay? What is that value that you got? 285,714 decimal 2857. Okay, I want you to write down that whole number. Write down every part of that number, please. What does that number represent? Eva says the number of burgers you can buy with $1 million. Do y'all agree? Is that burgers or is that dollars? That's burgers. Okay, so this is burgers. Oh. Okay, but can you buy a part of a burger? No, so we need to round up or down? Down. We need to round down. Okay, so I'm going to teach you something else. I'm going to teach you the sign for approximately. Okay, this is when you estimate something. You do 2 squiggly lines, just like that. Okay, 2 squiggly lines. That means approximately. Okay, so approximately 285,714 burgers. Yes, you write it in front of it. Because is this first number here our exact value? Is that exactly equal to our estimate? No, that's why we write this. It's approximately that, but it's not exactly equal. Okay? So it's just another symbol. You might see it on the ACT Aspire. You'll see it in the future. It's a good tool to have. Okay? Sounds good. All right, what did you get in scientific notation? 2.85714 times 10 to the this power. Where does the decimal naturally fall in this number right here? Back here. And it has to move how many place values? 5. Very good. So, let's go over number 2. Let's go over number 2. How many years does it take to earn $1 million if you're paid $30 an hour, work 35 hours a week for 50 weeks a year? Okay, what does this mean right here? A week, a year. What does that tell you? Per, right? Which means? Every time, which means? Unit rate. There you go. You can always count on Miss Shreve's kids for unit rate. All right, so $30 an hour, 35 hours a week, 50 weeks a year. What am I going to do with those numbers? Multiply them all together, right? Yes. 30 hours, $35 an hour times 35 hours will tell you how much you make in a week, times 50 weeks a year will tell you how much you make in a year. All right, so 30 times 35 times 50 tells you what? 52,500. And what is that number? Yearly salary. Very well said. Yearly salary. How much you make a year. Very good. All right, now I want to figure out how many years is it going to take to get to $1 million? Divide $1 million by 52,000. Stop talking. $52,500. Okay, what does that give you? 19.047 blah 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 blah, right? Okay, I'm going to estimate that. Okay? 19.047 years. Okay, am I going to round up to 20 or down to 19? Why down to 19? Okay, I want you to think about it realistically. It's going to take you 19 and some years. So if you're going to realistically give yourself a goal, would you round down or round up? Round up. So it'd be about 20 years. About 20 years. Okay, a dollar bill weighs 1 gram. How many pounds do $1 million bills weigh? Okay, so I'm going to write this down. $1 weighs 1 gram. 10 to the third is how many? 10 to the third is what? 1,000. Okay, 1,000 grams is 1 kilogram. 1 kilogram is 2-ish pounds. So that means $1,000 is how many pounds? 2.205 pounds, right? Okay, so what do I do now? Divide 1,000,000 by 1,000. Why? There you go. We want to figure out how many sets of $1,000 fits into $1,000,000, right? So we're going to divide it. So we're going to take 1,000,000 divided by 1,000, which equals what? 1,000. Okay, so that's 1,000 sets of $1,000 that fits into 1,000,000. Now what do I do with that 1,000? Well, when we multiply it, multiply it by the number of pounds it weighs, right? Each set weighs that much, 2.205 pounds. We know that there's 1,000 sets of those, so we multiply the 1,000 sets by what each one weighs, right? The unit rate. So 1,000 times 2.205 pounds equals 2,205 pounds. But I want you to write it in scientific notation, of course. 2.205 times 10 to the third power pounds. There you go. Okay, a dollar bill is this thick. How many yards is a pile of dollar bills? Okay, what am I going to do? Multiply this by 1,000,000. Okay. Times 10 to the 6th power, or 1,000,000, equals, I don't remember, 43. Okay, so the answer, I'm trying to remember what the answer is. Hold on. So after you end up solving this problem, you should end up with, that's not what I wanted to do, you should end up with an estimate of 119 yards. Just make sure that you transfer it from inches into the yards that you need.